Okay, so I'm going to be talking to you today about motion 2.3, which is a focus on an acceleration. And you'll notice that I wrote AKA, or also known as non-constant velocity. The objective says that you need to explain acceleration as A, a vector quantity that represents the rate at which velocity changes. B, it can be calculated by dividing the change in velocity divided by the elapsed time. C, it can be positive or negative. D, objects that have no acceleration can either be standing still or moving with constant velocity, meaning their speed and direction are constant. And E, as being constant when the change in an object's instantaneous velocity is the same for each successive time interval. So up until this point, we've really been focusing on constant velocity. And acceleration is known as non-constant velocity or changing velocity. So anytime an object's velocity changes, meaning it could speed up, it could slow down, or it could change direction, we're talking about acceleration. So prior to this, when we were talking about constant velocity, my little truck here would have the same displacement for each successive time interval. It would be going the same pace the entire trip. But now we're talking about situations where the object would be speeding up. The object could also be slowing down, or the object could be changing direction. Any three of those scenarios is considered acceleration. So for the first objective, or the first part of the objective, it says that acceleration is a vector quantity. So acceleration does have a direction attached to it, but it functions a little bit different than velocity. It also said it's the rate at which velocity changes. So then that leads us into actually calculating acceleration. So acceleration is the change in velocity, delta, I'm going to use that again, change in velocity divided by the time elapsed. So if I want to find the acceleration of an object, I need to find the change in velocity, and I also need to find the total time elapsed. Okay, so here's an example. Over 3 seconds, the truck goes from positive 2 meters per second to positive 8 meters per second. What is the acceleration? Well, here is my initial velocity, positive 2 meters per second. And here is my final velocity, positive 8 meters per second. And you'll notice that I indicated that they're both going in the positive direction. And this is over a time elapsed of 3 seconds. So my change in velocity would simply be a positive 8 meters per second minus my positive 2 meters per second. So that would give me a change in velocity of positive 6 meters per second. And then it told me that this was over a span of 3 seconds. So my time elapsed was 3 seconds. So if I just do a positive 6 meters per second divided by 3 seconds, that gives me an acceleration of positive 2 meters per second per 1 second. Now I know that that looks really weird, and you're either going to see that written as meters per second, or you're going to see that as written as meters per second squared. So this is how much did the velocity change meters per second over 1 second. That's your unit rate. That can also be written as meters per second squared. So now I've determined exactly what my acceleration is, and this object has a rate of acceleration of positive 2 meters per second. That leads me to the next part of the objective, and it says that acceleration can be either positive or negative. Now, this means something really, really different in acceleration, and I'm going to use a graphical example to show you exactly what I mean. And what I will do is I'll use the same mathematical example as we just did with the truck, but I'll show it to you graphically so that it makes a little bit more sense. So in the last scenario, our time was over a span of 3 seconds. And we said that we went from a positive, I'm going to need a little bit more space on this end. It said that we went from a positive 2 meters per second. Gosh, I'm making these lines way too far apart. We went from a positive 2 meters per second to a positive 8 meters per second over 3 seconds. So at 0, I was at positive 2 meters per second. Here's my starting time. So I started at positive 2 meters per second. And then 1 second, 2 second, 3 second later, I was at positive 8. So 1, 2, 3, 4, 5, 6, 7, 8. All right. So this is what this scenario looks like. My truck took 3 seconds to go from 2 meters per second to, or sorry, positive 2 meters per second to a positive 8 meters per second. So we determined that the rate of acceleration for this was positive, what did I say? Positive 2 meters per second. Because I said that my rate of change was from 2 to 8, so my change in velocity was positive 6 meters per second, and my elapsed time was 3 seconds. So I ended up getting a positive 2 meter per second velocity or acceleration, change in velocity or acceleration. So check that out. That's what that line looks like. Now, there are a couple things that I can determine from this graph. I can determine if the object is speeding up or slowing down. Well, if it goes from 2 to 8, I'm speeding up. I'm gaining velocity. I can also determine the direction of the acceleration, and the direction of the acceleration is very different from velocity. You'll notice that I have drawn 2 quadrants of the graph here, a positive quadrant and a negative quadrant, because I'll give you a negative example here in just a second. Wherever the velocity or the change in velocity is located is the direction of the acceleration. In this case, it's in the upper quadrant, therefore the direction is positive. Now, this last piece of the puzzle, it says part C, it can be positive or negative, refers to a combination of speeding up or slowing down and a positive or a negative direction. In this particular case, this object is speeding up and it's going in the positive direction. Well, check this out. Look at the slope. That results in a positive slope, meaning that this overall acceleration is considered positive. Now, at first you're probably thinking, well, yeah, duh, the direction is positive, so the acceleration is positive, but that's not accurate. Before, with velocity, positive and negative only indicated direction. Now with acceleration or non-constant velocity, I need to know, is the object speeding up and in what direction is it going? So let me show you exactly what I mean by that. All right, here you go. So I have a graph here for you. I've indicated that on my y-axis, that's my velocity in meters per second. I've indicated that I have a positive quadrant of the graph up here, a negative quadrant of the graph down here, and then my time is along the x-axis. Now, I have a scenario where an object over however much time this is, let's say 10 seconds, goes from positive 4 meters per second to negative 4 meters per second over 10 seconds. Now, there are really kind of 2 parts of the line here. Part A, then it crosses over the x-axis, and that gives me part B. So, let's look at part A first. First, let's determine, is this object speeding up or slowing down? When you're determining speeding up or slowing down an acceleration, you're going to use the values on the y-axis for velocity like absolute value. Well, this object goes from positive 4 meters per second to 0 meters per second. If I go from something, 4, down to 0, I'm slowing down. Because if I hit 0 meters per second, I'm no longer moving. Now, I also want to know what direction is the motion in this object. Well, check this out. It's above the x-axis, right here. It's in the positive quadrant, therefore, it's a positive direction. Now, the combination of these 2 events tells me whether it's positive or negative acceleration. This particular object is slowing down in the positive direction. Look at the slope that creates. It creates a negative slope. Therefore, that is negative acceleration. Now, I want to repeat. The negative acceleration has nothing to do with the direction alone like it did in velocity. It has to do with a combination of slowing down and in the positive direction. Because check out part B. Part B here is going from 0 meters per second to negative 4 meters per second. So that's from 0 to 4. If you go from nothing to something, guess what? You're speeding up, or you're moving further away from 0 meters per second. Well, now the line of part B is below the x-axis in the negative quadrant, so that's considered a negative direction. If I am speeding up, but in the negative direction, the combination of those events results again in a negative slope and again in a negative acceleration. So you can see that there are 2 scenarios to get a negative acceleration, which again is a combination of speeding up or slowing down and in what direction. Now, if I went the other way, like my other example, this entire line, no matter where it is going to result in positive acceleration. In this part of the graph, the object is slowing down, but in the negative direction. And in this part of the graph, the object is speeding up, but in the positive direction. A lot of people like to think of these as a combination of positives and negatives. They think of slowing down as a negative and speeding up as a positive. Well, if that's true, that would be a negative times a positive results in a negative. A positive times a negative results in a negative. If I slow down in the negative direction, that would be a negative times a negative, which results in positive acceleration. And if I speed up in the positive direction, a positive times a positive results, again, in positive acceleration. So you can kind of see the trends here in the graph, and I really think it's better to understand positive and negative acceleration by looking at it graphically. All right, the next part of this objective says that objects that have no acceleration can either be standing still or be moving with constant velocity. So if I have my truck and he is standing still, he is not moving, he's not changing position. Does he have a velocity? No. If he doesn't have a velocity, could he have an acceleration? No, because acceleration is a change in velocity. So this truck, if I were to graph this, I would just draw a line on the x-axis indicating that this object is going at 0 meters per second for some period of time. Now, if the truck was moving constantly, and let's say this is the positive direction, then I would have some sort of constant velocity. I'm going to say that that was relatively slow in the positive direction. If this object was turned around and moving with a faster constant velocity, but in the negative direction, I would show it like this. So anytime you see a flat line or no slope on a velocity time graph, you're talking no acceleration. And if you're talking no acceleration, you could either be talking about constant, the top line and the bottom line, or no motion at all, the center line. This object could also be changing direction that would result in some form of acceleration. Because if I have any change in velocity, meaning the speed or the direction, then I'm considering that acceleration. And finally, the last piece of the puzzle here is talking about constant versus non-constant acceleration. So the objective says that we would consider acceleration as being constant when the change in an object's instantaneous velocity is the same for each successive time interval. So you will have learned by now, or you will experience coming up in the next activity, that when I am looking at acceleration on a position time graph, I'm no longer going to see a straight line. I'm going to see some form of a curved line. So in this particular situation, I am starting at my motion detector and I am speeding up in the positive direction. Or according to the motion detector, I am speeding up away from the motion detector. So I know based on the position time graph that the direction is positive and that I'm speeding up because what happens, let me get my little special slopeometer out. This is a very fancy slopeometer. They're very expensive. If I put my pen on the line and then I increase, look what happens to my slopeometer. It gets steeper and steeper and steeper as I go up the line. So I know I'm going from a lower velocity to a higher velocity, so I must be changing. Now, on a velocity time graph, speeding up in the positive direction would look like that. So I am increasing my velocity over time. I'm speeding up, and I'm in the positive direction because I am in the positive part of the graph, or the positive quadrant, and I now no longer have a constant velocity where it would just be a boring flat line. I have a line with a slope, but notice, it's linear. So as you are speeding up, you are increasing your velocity at a constant rate, resulting in constant acceleration. Now, you're probably wondering, well, are there things other than constant acceleration? Yes, there are. There are things called jerk and pop and all that good stuff. We're going to focus just on constant acceleration. So anytime you are moving from a position time graph where you are speeding up or slowing down or changing direction, we are going to be doing that at a constant rate of acceleration. So it does mean that the instantaneous velocity, every point on this line, every instant, is increasing at a linear rate, resulting in constant acceleration. So that concludes my very lengthy, I apologize, video, but hopefully helpful video about acceleration.